is having Brugada syndrome.
Okay.
Then they'll go to the genetics team. And so that previously it was genetic counseling at Children's and Women's. There's now this inherited arrhythmia clinic.
Okay.
And that there are genetic counselors there. So they'll go and they'll have quite a broad testing for their genetic profile in terms of arrhythmias.
Yeah.
So they'll be tested probably for long QT syndrome, Brugada syndrome, CPVT, hypertrophic cardiomyopathy, quite a few things, depending on what the story is.
Yeah.
Where's that
It's currently at St. Paul's.
Okay.
Now, so the usual pattern is we see them and then we refer them there after we've sort of got some stuff sorted out. If they then have the genetic abnormality, then then their family members go and get tested for that specific abnormality.
Okay.
Okay? So imagine, heaven forbid your sister has a cardiac
I was just gonna say, so if my sister had it
How
and
long-
genetically she tested positive for it, then I go in, I get tested.
You just have that one gene tested.
Yeah.
And then you're given that information.
And
No,
so
that
okay, you've been tested positive, you have the Brugada thing. What do? Get an ICD put in?
Not necessarily.
Okay.
So
That's what I'd be like. Put an ICD
it's
in.
a huge, it's a huge quagmire
Okay.
because it's we don't know your risk of cardiac arrest.
Okay.
So your sister was given genes from your dad and your mom.
Right.
So say your dad had it and didn't know,
Okay.
and he gave that to your sister. The genes your mom gave to your sister could have been not very protective for her.
Okay.
Whereas we come to you and say you've got that gene
Okay.
from your dad. Well, the genes that you got from your mom could have been the protective half of the genes.
Oh.
So your risk of cardiac arrest isn't necessarily 100%.
Okay.
So absolutely, if you ever had syncope, you'd probably get it.
Right. Right.
If you had any funny business,
Right.
you'd probably get
Yeah.
it.
Okay.
The other thing we might do is put in an implantable loop recorder.
Right.
So I'm sure you've all seen these. That look like little flash drives. They're becoming smaller, so they're going to look like a little paperclip, and we'll be able to put them in the office actually.
Oh.
Sweet.
Yeah. So last 3 years, and so like young women usually have vasovagal syncope, right? So or they go out and get drunk. And
Yeah.
lose consciousness. Not speaking about anybody
Not everybody.
in particular, but you wouldn't want to put a defibrillator in somebody that had
Right.
vasovagal syncope and had a Brugada gene.
Okay.
It gets complicated too, where some of the genes aren't. So if you've got Brugada syndrome, you don't necessarily have a gene mutation.
Right.
We just haven't discovered it yet. So that gets more complicated. So imagine your sister's gene negative, and then you come in and you say, well, what should we do with me? And what we do is we do a procainamide infusion on you. We wouldn't do any genetic testing because
Right.
she doesn't have the gene.
Right.
And then we also don't want to do, say she had the gene, we wouldn't want to do every gene testing because we'd find something, right?
Good.
And then
I'd rather just not know.
Yeah, then you wouldn't know what to
Yeah.
do with the information, right? You'd be nervous.
Okay.
It makes you do a program on TV about prolonged QT of this family. One of the daughters did die. There was some like 7 kids, 7 deaths.
Yeah.
Then it turned out the mother had it, and then 2 more of the daughters.
So it gets complicated with family dynamics, life insurance.
Wow.
Yeah, interesting.
And is the long QT that you're getting, sorry, my other question was the long QT that you're getting when you're doing the exercise stress. So you're only seeing that when you're doing the exercise stress part of things, it's not a part of their normal.
Yeah, it's
ECGs?
only it's masked at rest, but it comes out. It's latent long QT syndrome.
So is it a type, like, is it a different type? Because there's
Yeah, usually type 1.
okay.
But there are different patterns. So we've done a bit of research on this, on how the QT lengthens with exercise, and
Yeah.
sometimes it lengthens and then shortens at peak exercise. So we have to scrutinize every part of that stress testing.
So that's those peak athletes that drop dead, have
Well,
this
so-
peak exercise stress that prolongs their QT and then they flip
So
into
that's
something
one of the
nasty,
things.
or
That's one of the things. But that table I showed you at the beginning.
Yeah.
So those are all athletes that died.
Yeah.
So,
So
any
there's
of
still
those
all of the different reasons.
All the
for
different,
it.
yeah.
Yeah. So it doesn't necessarily have to be that, but I think that table is so
Yeah.
comprehensive, and
yeah.
it just, if you divide it up into structural, electrical, and plumbing. Okay. So after the procainamide, and then so just maybe leading with a T, not a P. So the pericardiac arrest, they have their ECG, potentially a signal average ECG, then they get an echo, an angiogram, potentially an MRI. Then they go home, they come back for their adrenaline, procainamide, or stress test. And then we consider if there is any funny business in their RV, we might do what's called a voltage map. So this is not totally right. This was a epicardial VT case, but it gives you an idea of sort of what we're looking at. So this is the LV looking from the back, with this being the lateral wall here and this being the septum. So you're looking at the undersurface of the LV. So this is the map that's generated by the computer.
Okay.
Now we touch the wall with the catheter. Normal healthy walls should have a nice normal electrical signal. And when you touch scar, there's no signal or very fractionated, just not healthy signal. So what we do is we put the catheter in and we move it around, and then we see if the electricity looks normal or not. So that's called a voltage map. Sometimes we use the fancy, like this, computer mapping system, and sometimes we'll put the catheter in and move it around and see if the electricity looks normal or not. It costs us so much less money. Okay, so that's good for where you're worried about endocardial scar, because you're touching the endocardium. So, in particular, ARVC. So, ARVC we spoke about. So it's a disease of the desmosome, which is what keeps the cells together. So it attaches cell to cell, and it's not very strong, and so there's a lot of the cells will die more easily, and then they'll be replaced by fat and scar. It can be autosomal dominant with variable penetrance. I think that's all I want to say. So in Andrew's study, which Vancouver's a recruiting site, they had 28 patients with idiopathic VF. So that there wasn't anything identified, and 35 actually had a diagnosis at the end of that workup. This is sort of the interesting part. So this is just in a pie diagram, just what I've said. But of the diagnoses, these were the diagnoses that were made. So long QT syndrome being the most, but CPVT, even though it's quite rare, being quite common. Arrhythmogenic right ventricular cardiomyopathy, early repolarization, spasm, Brugada, and myocarditis. So the important thing I think of this, these people are now protected because they've got a defibrillator. But this group, this group, this group, this group, the Brugada group, all have family members at risk. Because these are all the inherited problems. So
That myocarditis, are you talking viral?
yeah,
cause?
viral myocarditis. So the you guys are so important here because not for many reasons, but in this realm, somebody comes in cardiac arrest and they're brain dead and they don't get a defibrillator. I want you guys to ask everybody to get genetic testing. Because usually what happens is, okay, everybody's emotional, don't want to ask the tough questions, but they're unfortunately dead, and they're not going to get a defibrillator, they're not going to see me because they don't need a defibrillator, but their family members are at risk, and you can protect them by getting genetic testing on the person who's dead, before they die. But they'll send the blood away for analysis, and and then you can test the family members for that out. Because it gets even more complicated when you don't know why the person died.
Yeah.
So the family member comes in and said, my brother died 2 weeks ago. I'd like to get tested. So then you have to test them for everything. And when you test them for everything, you're less good at testing.
Right.
I don't think we've ever done that
No.
No.
of people that have before
No.
they've
Yeah.
died.
Yeah,
You know, we always suggest that the family gets
yeah.
testing, but no, it's
So-
good to know.
So that lady, Ms. Tate, who kept having the long QT and falling off
Yes.
the QT. So we tested her. I think she still survived though. She
Yeah.
ended up going home and did well. But yeah, no, it's so crucial because it's so helpful for the family. Okay, and then so following the cardiac arrest, all the people with cardiac arrest receive a defibrillator, and then family screening depends on what's being identified, whether the genetics is positive or negative. So I think that's where I'm going to stop.
Matt, just one little question, if we can direct it to the docs then, if we take a blood sample, where does it get sent to, St. Paul's or what?
So the best thing to do is to call Tomoko.
Uh-huh.
Ms. Tomoko
Yeah.
is amazing, and then she'll get in touch with this genetic counselor called Julie Hathaway.
Okay,
And so that's what I did. I texted Julie and I said, hey, there's this woman who might not survive very long, and she's probably got long QT syndrome, and I really want to test her before she dies. And she came over. She had the blood. So it's a little complicated because the province doesn't necessarily pay for it.
Oh.
So you have to take the blood, put it in the right tubes, keep it, bank it, and then once there's been approval, send it off.
okay.
So when we get the right tubes, are we?
So
Well,
She would do
she'll
that.
tell-
She'll
she'll
tell us.
come. She'll take care of it.
Perfect.
So if you have this
Very-
situation, the best thing to do is go through
Either call me.
Tomoko
Yeah.
/ you,
Yeah.
and then you guys would follow up with his genetics.
Yeah.
Genetics. Julie.
And can we do that without our docs
I was
knowing?
just gonna say.
You know what I mean, or
You
do we?
call me.
Okay.
You call me.
Oh,
I don't know.
okay,
I,
good to know.
I might not answer it.
Yeah.
Yeah.
It's the middle of the night
Is
on
the
a weekend.
genetic testing being done locally or
Some of it
being
is.
sent somewhere?
Some of it is being done at Women's and Children's. They've got a good lab there, but not for all of it. So it depends on what the specific problem we're looking for is. But some of it has to be done in States.
And can they do like postmortem testing? Like,
They
is
do
it
some.
is that where it gets
So the
super complicated?
For study.
so it depends if the family wants autopsy or not.
Right.
But the pathologists know to take samples of the heart to send it for certain analysis, but it's still not as good as the initial
Just getting the
blood
blood samples.
samples.
Okay.
But absolutely, if somebody comes in and they have a cardiac arrest, and it turns out they hit their head and they've had a subdural, and that's they had brainstem injury or something like that, then it points us in the right direction, or not,
Right.
whether it was a cardiac cause or not.
So like when you're asking, when you're going through the questions, and you have people who've had like sudden death that they're just chalking up to an MI, but it's very remote. Like it's somebody that's been dead for 25 years or something like that, and then someone comes in arresting and that kind of thing. You haven't done any testing, or you have that in your family, and someone comes to you and said, "Oh, I have this. I have a great uncle who died of unknown cardiac something." Do you suggest that they talk about testing, or do you just stratify the risk factors, or?
It depends what. So, if somebody comes in and they do have a family history of cardiac arrest,
Yeah.
then it depends on the details. So, if somebody's 70, that's unfortunately the ischemic heart disease is so common.
Yeah.
Probably that's it.
Yeah.
But as people get younger and younger, it's more and more abnormal. We do test them, particularly if there are suspicious things like drownings. That's long QT syndrome until proven otherwise. While exercising is usually not normal.
Yeah.
So it depends on the specific details, but we, the Casper study is for people with either family history of cardiac arrest or that have had a cardiac arrest.
So with the drowning thing, what is, like, just if someone drowns, you